In this video, we're going to discuss how to factor trinomials. Remember the previous video that we did, we multiplied two binomials together. So let's say that we had x and then plus 7, and then we had x and minus 9. So in this one we would do x times x, and then the outer terms would be negative 9 times x. The inner terms would be positive 7 times x, and then the last terms in both sets of parentheses would be 7 times negative 9. And we would get x squared. Negative 9 times x is negative 9x. 7 times x is 7x. And 7 times negative 9 is negative 63. And we would combine our two middle terms. We get x squared, and then negative 9 and positive 7 is negative 2x, and then negative 63. So in our last video we started here and we ended here. In this video we're going to do the exact opposite. We're going to start with our trinomial and we're going to get back to the product of two binomials. Remember, product just means multiplication. Let's start with this trinomial and then end with a factored product of two binomials. So what we're going to do is we're going to multiply the leading coefficient 1 in green times the constant negative 63. So when we multiply 1 times negative 63, we're going to get negative 63. So our goal is to find two numbers that multiply to negative 63 and that add to negative 2. So those two numbers are going to be negative 9 and positive 7. Because negative 9 times 7 is negative 63, and negative 9 plus 7 is negative 2. So we are going to rewrite the trinomial, but instead of negative 2, we're going to put negative 9 and positive 7. So it's 1x squared negative 9x plus 7x minus 63. Notice that this trinomial and this polynomial with 4 terms are exactly the same because negative 9 plus 7 is negative 2. So it's the same thing, just written differently. So now we're going to look at the first two terms. The first two terms we have here are 1x squared and negative 9x. And we're going to factor out what they have in common. Well, this first term has 2x's, x squared, and the second term, negative 9x, has 1x. So they both have an x in common. And what we're left with is x minus 9. And we're going to write whatever's in parentheses, the x minus 9, we're going to write that one more time. So x minus 9. And then we're going to look at the second pair of terms, 7x and negative 63. And we're going to figure out what number would go on the outside to make it 7x minus 63. And that number is going to be 7. So I'm going to change the colors here so that you guys can see this next part a little bit better. You can double check your work because if we have 7 times x and 7 times negative 9, that would give you 7x and negative 63, which are the two terms above. If you multiply x times x, that gives you x squared, and x times negative 9 is negative 9x, which gives you the two terms above. So that's a way that you can check your work. If you can't remember, think about what goes on the outside, or in the inside of the parentheses. You can divide. So you can do 1x squared here. You can do 1x squared divided by x, and gives you, divided by this x, gives you x. You can do negative 9x divided by x, and that gives you negative 9. So you can divide in order to find out what goes on the inside as well. We're going to put what's on the outside of the parentheses inside one parentheses. So it's a positive x and a positive 7. And then we're going to put the x minus 9 in one parentheses. So this is our factored form. X plus 7 times x minus 9, which is what we started off with. X plus 7, x minus 9. So we just worked backwards. We'll do a couple problems from the homework, starting with number 8. So again, we're going to multiply the leading coefficient and the constant. So in this case, it's 1 is the leading coefficient times our constant, which is 63. 1 times 63 is 63. And then we're also going to take our negative 16 and we're going to figure out what two numbers add to get negative 16 and multiply to get positive 63. So think about all the numbers that multiply to get 63. Right? You can go in order if you're not quite sure. So 1 times 63, 2 doesn't go into it, 3 goes into 63 21 times, 4 doesn't go into it, 5 does not, 6 does not, 7 goes into 63 9 times, 8 doesn't go into 63, we already have 9. So out of these three combinations, do we have to keep going, or can we find something that multiplies to get 63 and adds to get negative 16? Well, in order to get negative 16, we'd have to have combined two negatives if it was 7 and negative 9. So we could do negative 7 and negative 9. That would give us negative 16. Let's see if that would work here. negative 7 times negative 9. That would work, because we have a negative times a negative is a positive, and a negative 7 plus negative 9 is a negative 16. So that would work. So we're going to rewrite the trinomial, but instead of negative 16m, we're going to put negative 7 and negative 9m. So we have m squared, or 1m squared, minus 7m minus 9m plus 63. All right, again, we're going to take the first two terms and factor out what they have in common, which is an m. M squared divided by m is m. Negative 7m divided by m is negative 7. We're going to rewrite that, whatever's inside the parentheses, again. And it's going to be m times negative 7. And then we're going to figure out, okay, negative 9m divided by m is negative 9. Again, we can double check our work by, let's see, this is m, let's put this in the same color. M, and let's put this into green as well. You can double check your work. Negative 9 times m is negative 9m. Negative 9 times negative 7 is positive 63. M times m is m squared, and m times negative 7 is negative 7m. It's just a way to double check to make sure that your work is correct. So we're going to take whatever's on the outside of the parentheses and put them on the inside of one parentheses, which is going to be m minus 9 times, and then whatever the other parentheses is, m minus 7. But we only take one of the two. So this is our final answer. This is the factored form. So when it says to factor a trinomial, you're going to get a product of two binomials. A way that you can check your work is to multiply these two using FOIL or the box method. So you do get m squared minus 7m minus 9m plus 63. Combine the m's, you get m squared minus 16m plus 63, which is what we started off with here. So it checks. And we'll do one more example together. We're going to multiply negative 15 and 1, the constant and the leading coefficient, which is going to be negative 15. We want two numbers that multiply to get negative 15. And then we're going to take the coefficient of the middle term, which is negative 2, and we want two of the same numbers that add to get negative 2. So you can figure out, okay, what two numbers multiply to get 15. We have 1 times 15, 2 doesn't, 3 times 5, 4, 5, 6, 7, 8. Those are all the factors of 15. You can play around to see which ones also add to get negative 2. So we would get negative 5 and positive 3. Oops, I don't need to put the positive twice. That would give us a negative 2, and it also has to work for multiplication. So if we did negative 5 and positive 3, would that also give you negative 15? Yep. So we're going to rewrite this trinomial with an expanded polynomial with 4 terms, where we have p squared plus We could do minus 5p. Minus 5p plus 3p minus 15. We take our first two terms, factor out a p, because they both have a p. P squared divided by p is p, and negative 5p divided by p is negative 5. Whatever is in that parentheses, we put in this parentheses. And then now we're going to look at these second two terms. We do 3p minus divided by p is 3. And we always want to check to make sure that what we have done thus far is correct. And remember, we can check by multiplying. 3 times p is 3p, 3 times negative 5 is negative 15. P times p is p squared, p times negative 5 is negative 5p. So what we have done so far is correct. And I'm going to put these in different colors. The 3 and the p we're going to put in blue. So this is red. So it's going to be in one parentheses p plus 3, and in the other parentheses we're going to only take one of the two parentheses, p minus 5. So this is our solution. And again, to check our work, we can multiply using the box method or the FOIL method. If we put p plus 3 and p minus 5, and we did p times p is p squared, p times negative 5 is negative 5p, p times 3 is 3p, and 3 times negative 5 is negative 15. Combine this diagonal because they're like terms, and we're left with p squared, negative 5 plus 3 is negative 2p, and minus 15. So this here does check because it's the same as what we started with up here. So this here is your correct answer.